One more problem from ray optics. Students preparing for NEET 2021 and thereafter. Very simple. It's not for JEE main or advanced. Now look at the statement of the problem. A ray of light falls normally on a refracting face of a prism. You can look from here. PQR is a glass prism. This angle is called the angle of the prism and is also called the refracting angle. This is the incident ray. BD is the incident ray, and you can look here. This is not bending, this is going straight. Why this is going straight, I will explain mathematically. And the prism has a refractive index mu2 is 1.5. Find the angle of the prism. We have to find this angle. If the ray just fails to emerge from the second refracting surface, PR is the second refracting surface, and this ray at this point is not able to go to this side. This is what the problem wants to say. Now, if you look at here, BD is the incident ray, so the angle of incidence is 0. Why the angle of incidence is 0? This is the normal. This is the normal, and this is also the incident ray. So they are overlapping. So the angle of incidence is 0. And we know from Snell's law, sine of the angle of incidence on this side by sine of the angle of refraction on this side is equal to mu of this medium by mu of this medium. So this medium I have taken as mu1, this medium I have taken as mu2. So if you cross multiply, mu1 times sine I is mu2 times sine r. Since I is equal to 0, I is 0, sine 0 is 0, 0 into mu1 is 0. So the left hand side is 0. So the right hand side will also be 0. But if you look at the right hand side, these are product of two things, mu2 and sine r. Since mu2 is not 0, therefore sine r has to be 0. So therefore sine r has to be 0, and in sine table, therefore the value of r is equal to 0, means this incident ray BD is not refracted, moves straight. Had it moved in a different way, then there would have been some angle of refraction. So since r is equal to 0, so it moves straight. Now it arrives here. At this point, it is trying to go from denser to rarer medium. Now if you look at this triangle PDE, this angle is 90, this is A, so this much will be 90 minus A, because sum of the three angles is 180 degree in a plane triangle. This OEN is the normal, so this is 90 minus A, this angle is 90 minus A, and since this is normal, means making 90 degree with this surface, therefore this angle has to be A. So at this point, the ray BD here, this part, the DE part of the ray inside the prism, you can consider it as an incident ray. It is trying to be refracted, trying to go to other side. So if this angle is 90 degree, means you can say it just fails to come to this side. Now, so that is what I have explained, how in triangle PDE, this angle is A, this angle is 90, therefore PED is 90 minus A. And this is the normal, therefore this angle is A. So here we apply, we have to apply the Snell's law. Sine of this angle by sine of this angle will be mu1 by mu2. Or you can say mu of this medium times sine of A will be mu of this medium by sine of 90. So that is what I have shown here. So mu2 sine A is mu1 sine 90. So since sine 90 is equal to 1, since sine 90 is 1 times mu1 is mu1. So we need to find sine A. Mu2 is multiplied. I take it to the right side. It is divided. So if this angle A is equal to the critical angle, then this ray will travel like this. So sine A is equal to 1 over mu2. The value of the prism is given as 1.5. So A is equal to sine inverse of 1 by 1 over 1.5. That comes out to be 41.8 degree, right? So what is to be understood is when you apply Snell's law, normally you make a mistake. For example, here, sine of this angle times mu of this medium will be sine of this angle times mu of this medium. That is how you apply. Right. So I think it is clear to you. It is not meant for JEE main or advanced. It's meant for NEET exam only. Further doubts, you can clarify and ask me. I will be soon uploading few more videos from ray optics, wave optics, and other different chapters very soon. Thank you.